This is part 3 of chapter 2. The first two slides are review slides, which are taken from last time PowerPoint. Okay, so just go over them and make a quick review of what we have explained. Expression could be made of constant, of variables, and also expression, they could be combined with one another. So we may have one expression and then some operators and another expression, and again within an expression you may have functions such as square root, for example, or power within an expression, and this is what we will see at the end of this lecture. Let us first remember what are the operators, like the arithmetic operators, okay, which are the symbols that are used to perform basic mathematical operations like addition, subtraction, multiplication, division, and the percentage sign, which is a modulo, okay. So here are the operators, which are called arithmetic operators, and here are the examples, and we have covered this, and this is very simple. Now for the relational operators, these are symbols that are used to compare two values, okay? For example, less than, greater, less than or equal, greater or equal, whether it is equal or not, or whether it is not equal. So for example, 10 is less than 5, it's false, greater than 5 is true. So these are called relational operators, okay? This will return true or false value, okay? So, for example, 10 is less than or equal to 5, it's false. 10 greater than or equal to 5 is true. Whether we are comparing these two numbers, is 10 equal to 5, so we use double equal, and this is false. And 10 not equal, so this is a not. So it returns true if both values are not equal, okay? So this is the not operator, so 10 is not equal to 5, that's true. And then we will move to the logical operators, okay? They are used to combine multiple conditions into one condition, and they are called logical operators, and they will return again true or false. For example, here I have one expression, 10 less than 5, and on the right I have 12 greater than 10. So 12 greater than 10, this expression is true. 10 less than 5, this expression is wrong. So you have false and true, it will return false. So the AND, which is called the logical AND, it returns true if all conditions are true. Yani before the AND and after the AND should be true, and all expressions should be true in order to return true. Now this is the logical OR. It returns false if all conditions are false, otherwise it will return true. For example, 10 less than 5 is false, 12 greater than 10 is true, so it will return true, okay? It will return only false if both all conditions are false. Now this is the not operator, so it will return true if condition is false and returns false if it is true. So it is the not, okay? So for example, here you have not, okay, and then I have this. Okay, so if this is false, what is inside this expression is false, the not of false will be true. So 10 less than 5 is false, whether we are ending it with 12 greater than 10, which is true. So this expression will give us false, so not false will give you true, okay? Next, we have the increment and decrement, which we have covered, okay? So which add 1 to existing values. So for example, if you have a equal to 5, a plus plus will increment a to 6, and decrement, again, if you have a is 5, decrementing a is 4, okay? And also we have covered the examples of pre-increment and post-increment. We have talked about them. Now this is an example of the post increment. So here you have I is equal to 5, okay, and then you have an integer j, and then you have j is equal to a plus plus, and this is post increments. So which means that if you are going to print I, so I is equal, this percentage d, okay, will print I, this I, okay, it will refer to this I, and this again j is equal, this percentage j will print j. Okay, so what are the values of I and j in this case? So in this case I will be equal to 6, okay, because I is incremented from 5 to 6, and j will be equal to 5 because j is assigned to 5, which is I, and then I is incremented, okay, and the output shows the result. And this is another example now on how to print two integers, showing you the fields percentage d corresponding to I and j. So end up with I is equal to 6 because I is incremented, and j is equal to the value of I, which is incremented, which means j is equal to 6. You increment I and j is updated after the increment. And here is another example of the assignment operator. Again, okay, how we use the plus equal, minus equal, star equal. We have seen them last time, so I will not go over them again. Now, usually how we evaluate expressions, okay, usually we make calculations and we return result. We have to return the result out of this expression. Example, in this expression, okay, we have 3 plus 2 and double equal 5, okay, so here we are comparing whether 3 plus 2 is equal or not to 5, so we use the double equal. So this usually will return 1 if it's true and 0 if false. In this case it will return 1, the result is 1. Now another expression is simply made of numbers, a equal 5 plus 3, so it will return 8. So the order of the evaluation of different parts of an expression, especially when you have many terms and you have many operations, so you know about the order. So the order is the same principle which you have learned already in mathematics, okay? So this is an expression with multiplication and addition, so you know it will be, the multiplication is priority, so you will consider 2 times a first, and then 3 times b, and then 4 times c, and then you add up all the 3 terms together, and this will give you 44, having a is equal to 5, b is equal to 10, and c is equal to 1. Now let's study the priorities of operators when you have a complex operation. For example, we may have arithmetic operators, relational operators, logical operators combined in expressions. So how you are going to evaluate them? So this is the list of priority. Parenthesis is considered the highest priority, and then you have the not, the increment, the decrement, etc. As you can see here, we have 9 classes of priority in addition to the logical priority, and everything is shown here. Just note that all of these priorities, if they belong to the same class, okay, they will be treated in order, okay, and also you can start from left to right, except the unary operators like row 2 and row 9, okay. In this case you evaluate them from right to left. So now let's take this example. We are going to evaluate this expression, a star equal b plus equal 5. Okay, so we will start from the right side, okay, since this is priority 9 in the previous slide. So we have b plus equal 5, it means b equal b plus 5. In this case b equal 4, so you will end up with b equal 9. A star equal 9, it means a equal a times 9. In this case you will end up with 27, as a is equal to 3. Now for the second expression you have not double increment here, so you have increment which is double minus, double equal, plus plus, and 1 and not b. Okay, so for the increment of a, if a is equal to 1, you will end up with 0, not 0 is 1. On the other, we are checking whether this term is equal to this term. So the second term is not b, so it's 0. You are incrementing the 0, so it's 1. We are checking whether this side is equal to this term is equal to this, which in this case is true. So the result of this expression is 1. Now, this is an example of more complex expression which we will solve during the class. Okay, please try solving them and then we will go over them during the class. And then here we need to notice that whenever we have arithmetic functions, we have to include a special library, which is math.h. So these functions are defined in library math.h, which should be included, such as the exponential, the square root, the steal function, the floor function. So this we will use later. Okay, and to use them you have to include math.h. Now let us go to an example where we have to make what we call type conversions. So what does it mean? We have to add the type before the expression. When do we add type before expression? So let us assume we have two integers a and b and we are going to make a division, a over b. So in this case we will declare c as a float. Now when we want to print c and when we want to see the value of c, if we put c equal a over b, so the result of dividing 5 over 2 will be 2.00, and definitely we are losing precision, so it should be 2.5. So in this case we have a solution if you want to put a and b as a float, but this is not the correct solution. The solution is to force the result to be float, okay, and to be with high precision. So in this case we write the type of the result before the expression. So simply if you write c and the type float and a over b with a b integer and c float, you will end up with 2.5. Okay, so this will help you to solve exercise 11. So we will discuss all this again in our next Zoom meeting.